Welcome to class. Today we are going to discuss some important problems in the topic polynomials. Already we discussed about the polynomials. How can we represent the polynomials in the graph, and how should we find the zeros of the polynomials and roots of the polynomials. So here we are going to discuss some important problems. Here we are having the first one. If p of t is equal to t cube minus 1, find the values of p of 1, p of minus 1 and p of 0, and we are having p of 2, p of minus 2. So here given polynomial p of t is equal to t cube minus 1. This is the polynomial we are having, and we need to find the values of p of 1, p of minus 1, p of 0 and p of 2, p of minus 2. For the polynomial, we want to find the values of these all values. How we will get the values? See, how should we find that? So we should write the given polynomial b, p of x is equal to t cube minus 1. So we need to substitute the values of p of 1, minus 1, 0, 2, minus 2. These all 5 values we need to substitute in the value where we are having the p of t. So if t is equal to 1, then what we'll get? So p of t is equal to 1 cube minus 1. 1 cube means 1 minus 1. Then we are having 0. So therefore p of 1 is equal to 0. This is the way we are finding. If t is equal to 2, then what will get? P of 2 is equal to 2 cube minus 1, and 2 cube means 8. 8 minus 1 is equal to 7. Therefore p of 2 is equal to 7. This is the value. And if we are having t is equal to minus 1, p of minus 1 is equal to minus 1 whole cube minus 1. So minus 1 means we need to multiply minus into minus into minus. So we are again having minus 1, minus 1, minus 1, minus 2. Therefore p of minus 1 is equal to minus 2 the value. And if t is equal to, so 1, minus 1, 2 and minus 2, I am taking order, I am writing p of minus 2 is equal to minus 2 whole cube minus 1 is equal to minus 8 minus 1. Then we are having minus 1. Therefore p of minus 2 is equal to minus 2. And the last one we are having here, if t is equal to 0, then p of 0 is equal to 0 cube minus 1. So we are having minus 1. Therefore p of 0 is equal to minus 1. So in this manner we can find the values of the polynomials by given values. Coming to the one more problem. Here I am taking the one more problem. So check whether 3 and minus 2 are zeros of the polynomial x square minus x minus 6. Here given polynomial, we should consider this one as p of x. I am writing the given polynomial as x square minus x minus 6, and is given the values minus 3, minus 2, 3 and minus 2. These values are zeros of this polynomial or not? We should check. So let us consider p of x is equal to x square minus x minus 6, and we have to 3 and minus 2. So we should take the values as we have 3 and minus 2. So and we should substitute the 3 and minus 2 in the given polynomial. Then only we will get the values whether they are zeros of the polynomial or not. Means the value should be equal to 0, then it is comes under the zeros of the polynomial. How can we take? So p of x is equal, so we are having x square minus x minus 6, and if x is equal to 3, then p of 3 is equal to 3 square minus 3 minus 6, and 9 minus 3 minus 6, 9 minus 9, then it will become as 0. And if x is equal to minus 2, then what will get? Minus 2. P of minus 2, minus 2 square minus 2 minus 6, and here 4 minus 2 minus 6, then we are having the values here. So here already we are having minus 2, minus into minus of 2 we should take, and 6 minus 6 is 0. Minus 2 square 4, and minus of minus 2, minus into minus plus 4 plus 2 minus 6, and 6 minus 6 0. So the given values zeros of the polynomial we can show. So hence given values 3 and minus 2 are zeros of the polynomial p of x is equal to x square minus x minus 6. So in this manner we can prove the values. And here we are having one more problem. Here I am taking find a quadratic polynomial if the zeros of it are 2 and minus 1 by 3 respectively is given. So here we are not having any polynomial for that question, and we are having the only the roots or zeros of the given polynomial. But how should we consider? See, given zeros of polynomial are 2 and minus 1 by 3 is given. So how should we take the quadratic polynomial? So we are having general polynomial. Here let us consider general quadratic polynomial as ax square plus bx plus c, and where we are having the a value is not equal to 0, and let its zeros be what he given here. For these zeros, let the zeros of ax square plus bx plus c are alpha, beta. So we need to take the given values as alpha and beta. Therefore let alpha is equal to 2 and beta is equal to minus 1 by 3. So we should consider the values as taking the sum of the zeros and product of the zeros. So sum of alpha plus beta is equal to 2 plus minus 1 by 3. Then we can take 6 minus 1 by 3 is equal to 5 by 3, and product of alpha beta is 2 into minus 1 by 3 minus 2 by 3. We are having the values sum of the values and product of the values. So we should substitute these values in the part we are taking the quadratic polynomial. So we should consider the quadratic polynomial p of x is equal to ax square plus bx plus c, and is equal to the k of x square minus alpha plus beta x and plus alpha beta. This is the formation we can identify where k is any constant we are having. This is the one of the required polynomial, quadratic polynomial for the given values of the zeros, and we need to substitute the values in this equation. Then we will get the required quadratic polynomial. See, therefore I am taking p of x is equal to k into x square and minus alpha plus beta value is here we are having. This is the 5 by 3. I am taking here 5 by 3 x, and plus alpha beta is minus 2 by 3. So it is not in the quadratic polynomial. So let us consider the values here by keeping the, if k is equal to 3, then what we'll get? P of x is equal to, if we are taking 3, otherwise we are taking the LCM for this also, we will get the k value. Keeping the k value as 3 and x square minus 5 by 3x and minus 2 by 3x. Then if I am multiplying with 3 to the complete polynomial, then we will get the clear quadratic polynomial. 3 into x square, 3x square, and 3 into 5 by 3x and minus 2 by 3 into 3. Here can cancel the values, 3 will be cancelled, here also 3 will be cancelled. Then we are having the required quadratic polynomial as 3x square minus 5x and minus 2. This is the way we can identify the quadratic polynomial for the known values of the zeros. One more problem I am explaining here. Verify that 3 minus 1 minus 1 by 3 are the zeros is given. So zeros are 3 minus 1 minus 1 by 3 is given, and a cubic polynomial is given. So p of x is equal to 3x cube minus 5x square and minus 11x and minus 3, and then verify the relation between the zeros and the coefficients. So relation, we need to find relation between zeros and coefficients. So here this is the question I am writing simply way. I will give you the complete solution here. Zeros of the cubic polynomial is given 3 minus 1 minus 1 by 3 and the cubic polynomial is given 3x cube minus 5x square minus 11x minus 3, and we need to verify the relation between the zeros and the coefficients. How? See, let us compare the given polynomial in our general cubic polynomial. So let us consider the given polynomial with our general cubic polynomial. So therefore I am taking this one as a general cubic polynomial as here ax cube plus bx square plus cx plus d we are having. This is the general cubic polynomial. We need to compare the values here. So for the given polynomial p of x is equal to 3x cube and minus 5x square and minus 11x minus 3. So therefore I am comparing the both the cubic polynomials here to get the ABCD values. So here the coefficients are here for the both the polynomials. A is equal to 3 and b is equal to, we are having minus 5, and c is equal to minus 11, d is equal to minus 3. So we got the coefficient values here. So what should we take? How can we find the cubic polynomials zeros? By representing these zeros as given 3 minus 1 minus 1 by 3. So therefore we need to take here if x is equal to 3, then p of x, what we are having the value here 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3, and 3 into 3 cube means 3 3s are 9, 9 3s are 27 we are having, and minus 5 into 9 minus 11 into 3 minus 33 minus 9, and we need to get the value 27 3s are, so 3 7s are 21, and 6 81 minus 5 9s are 45, and here we are having already minus 36, then 81 minus we are having here 81, so both should be cancelled. So zeros of the polynomial means the value where we are substituting in the x terms, then we will get the complete cubic or the quadratic polynomial should becomes 0. So this is the one of the 0 value of the polynomial, and if we are taking x is equal to minus, what we will get p of minus 1 3 minus 1 whole cube minus 5 into minus 1 square minus 11 into minus 1 minus 3, and here minus 3 minus minus will be become as plus, and minus 5 and plus 11 minus 3, then we are having 11 minus 11, it is also 0, and if x is equal to minus 1 by 3, so what we will get here p of minus 1 by 3 is equal to 3 into minus 1 by 3 whole cube minus 5 minus 1 by 3 whole square minus 11 minus 1 by 3 and minus 3. So after substituting the values 3 into 1 by 27 minus 5 into 1 by 9, and minus into minus plus 11 by 3 and minus 3, then 3 1s are 3 9s are 1 by 9 minus 5 by 9 minus here I am taking for these two terms at a time LCM, so minus 11 by minus 11 minus 9 by 3 here. So in all cases we are having the value is here LCM should be 9. This is the different case here directly I took here LCM, and by taking here then we are having minus 1 minus 5 and minus 33 minus 27. We need to take the value is here, so again we are having minus, we are 1 by 3 means minus we are having, so here minus, so here minus minus it will be become as a plus, then we are having LCM 339 and minus 7 means here it is a become as a plus. Here the value is 33 minus 33 by 9, it is nothing but the value is 0. So here both the values minus 33 plus 33 will be cancelled. So in all the cases he given the value are zeros, so it is satisfies. Then our general cubic polynomial is this one, and we need to get the relationship between that. So here now let us consider, let us take the values alpha is equal to 3 and beta is equal to minus 1 and gamma is equal to minus 1 by 3. So we need to compare the values here. So we are taking here some of the roots here we are having. Therefore alpha plus beta plus gamma is equal to 3 plus of minus 1 plus minus 1 by 3 we are having here 3 minus 1 and minus 1 by 3. Then how can we get this value as here? By substituting these values, by taking the LCM. Here I am taking 3 and 9 minus 1 we are having 3 minus 1, then I am having 9 minus 4 by 3 and I am having 5 by 3. Then I am writing this one as a minus of minus 5 by 3, verifying the values of the minus b by a. So b value is we got here minus 5 and the value relation between the this one is this only, and product of the roots alpha beta and beta gamma and gamma alpha, how should we take? So alpha beta 3 into minus 1 and plus, and beta gamma minus 1 into minus 1 by 3 plus, and we are having alpha gamma 3 into minus 1 by 3, then here minus 3 and we are having 1 by 3 and we are having minus 1 3 by 3, and here 3 will be cancelled and we are having minus 3 plus 1 by 3 minus 1. If we are getting the values here minus 4 plus 1 by 3, then we are having minus 12 by 3 plus 1 and minus 11 by 3. Then we are having this value as directly we are having c by a, and this is also relation of these coefficients and the zeros. And the last one we are having alpha beta gamma product values of the roots of the cubic polynomial. We are taking 3 into minus 1 into minus 1 by 3, then I am taking this one as 3 by 3. It is nothing but I will write this one as minus of minus 3 by 3. Then it is the minus d by a. This is the value we are having here. So in this manner we can find the relation between the roots and the coefficients. So it is satisfies. In this manner we can show the relation between the coefficients and the zeros of the cubic polynomial or the quadratic polynomial. Same procedure we can follow for the solution, and by using the division algorithm, one more problem we are having here. The fifth one I am taking. So he is given the value, this is the here, divide 3x square minus x cube minus 3x plus 5, 3x square minus x cube minus 3x plus 5 by the value is x by x minus 1 minus x square, and verify is asking, and verify. So let us consider the division algorithm first of all. Whenever we are going to check the division for the polynomials, we should keep division algorithm in our brain. There is the dividend is equal to divisor into quotient plus remainder. So we are having this division algorithm in our brain. We can check our solvation is right or wrong after completion of the solvation. He is asking divide the first polynomial with the second polynomial. How should we divide? So before going to divide the polynomials, we need to check either it is in the order or not. Means it is should be in the decreasing order or increasing order, and any zigzag manner we are having. So here we need to get the x cube term first, then after we are having the x square, then after x and the constant term. Here also we are having the divisor in the zigzag manner, x minus 1 minus x square. We need to convert this one in the decreasing order. First we need decreasing order. So I am taking therefore dividend as minus x cube plus 3x square minus 3x plus 5, and divisor as minus x square minus x minus 1. So I am writing this one, we need to divide. So let minus x cube plus 3x square minus 3x plus 5 divided by minus x square minus x minus 1. So this is the correct way only we can divide. I am taking our regular division, the value is minus x cube plus 3x square and minus 3x and plus, and I'm taking this one as by dividing with minus x square plus x minus 1. So always we should cancel the highest degree term in each and every step. So here we are having minus x cube, here we are having minus x square. If we are taking this value as x only, it is possible to divide this. So I am multiplying minus x square plus x minus 1 with x. So what I am getting? So x into here minus x square minus x cube, and x into x plus x square we are having, and minus 1 into x minus x we are having. So whenever we are dividing means we should subtract here, the sign will be changed. So minus x cube plus x cube will be cancelled. Then we are having only the 2x square and we are having minus 2x. So here we are having the constant term, but take down the value here as plus 5. Then check out, x square term is there, only we need to get the value as only plus 2. So plus 2 into minus x square minus 2x square. So plus into minus, minus we are having. So already here we are having minus, here also we are having. When we change the sign, this will be not cancelled. So better to take the value minus, then you will get it is the plus x minus 2 we are having. So minus into minus plus, and x square into 2x. This is the way we can cancel the values. So here minus 2x minus into minus plus 2 we are having. Then I'm changing, it is already became plus minus, and it is plus, it is minus. So we cancel both the terms of the x square terms. Then we are having here, then these two terms plus minus will be cancelled, and we are having the here the remainder is 3. So this is the closing step. Why should we stop the division means that is the variable term having less than value of the divisor variable terms of the degree power. We can check here only the constant value, here we are having the polynomial. It is not possible to divide this, so we are having the values here. Already we have divisor value and dividend value. By taking the quotient and remainder, we will get the right answer or not. This is the verification I am showing here. Verification, how should we check? By using division algorithm. So we are having dividend is equal divisor plus quotient, it is the into plus remainder. So dividend value what we are having, minus x cube plus 3x square minus 3x plus 5, and divisor value is minus x square plus x minus 1. We need to multiply with the term quotient, and this is the x minus 2 value, and plus we are adding the remainder. This is constant, no need to change anything for this one. We are multiplying each term of the polynomial to the each term of this polynomial. So minus x square into x and plus x into x minus 1 into x, and next one minus 2 into minus x square plus 2x square, and minus 2x and minus into minus plus 2 plus 3 we are having. So in this term to complete terms and this term to complete terms we multiplied. Then we are having minus x cube and plus x square minus x, and we are having again 2x square and minus 2x, and we are having 2 plus 3 5, and I'm taking here minus x cube and x square is there, and plus 3x square and minus x minus 2x minus 3x plus 5. So we are having the values LHS is equal to RHS, hence proved division is perfectly. And one more problem is there here. We need to represent the polynomial in the graph. How should we represent the given polynomial in the graph? I'm going to explain here. So this is the last one. Here we are having, so we are having the polynomial taking p of x is equal to x square minus x minus 12. This is the polynomial I'm having. So how can we present this polynomial in the graph means we should take the list of the values of the polynomial. So how should we consider? So first draw a table to get the values, and in this case everyone having doubt how many points, how many values we should take. So maximum we should take 5 or 6 values by taking the 0 also. So less than values and positive values including 0, this is very good to represent the polynomial in the graph sheet. So to get the zeros of the polynomial, so how can we identify means where the polynomial cuts are intersecting or bisecting the x-axis, that is called the values of the zeros of the polynomial. We know that. So we are taking the values here x, and we are taking the y value as p of x. The value of p of x is nothing but the value of y to represent the x and y coordinates in the graph sheet. So scale units also I will say how should we take. So right, I'm taking here x values first. To get the values, I'm taking some values here. I'm starting for this one, -4, -3, -2, -1 and 0 and 1, 2, 3. So all are equal. -4 to 4 I took here the value of x. So how should we get the p of x value means we need to substitute the x value in the given polynomial, then only we'll get the p of x value. That is nothing but the value of the representation purpose of the graph. So if x is equal to -4, what we'll get? So p of -4 will get. So p of -4 means -4 square, minus into minus plus 4 and -12 we are having. So 16 plus 4 minus 12, then we are having 20 minus 12, this is the value 8. We should take here as 8. And if x is equal to -3, then p of -3 is equal to -3 square, minus into minus plus 3 and -12 we are having 9 plus 3 minus 12, then we are having 12 minus 12, this is the 0. Then we should take the value as y 0. And if x is equal to -2, then p of -2 is equal to -2 square and plus into minus plus 2 minus 12, and here 4 plus 2 minus 12, then 6 minus 12 we are having -6. Take this one as -6. And if x is equal to -1, p of -1 is equal to -1 square plus 1 minus 12 and 1 plus 1 minus 12, then we are having -10. The value is here -10. And if x is equal to 0, what will get? P of 0 is equal to 0 square minus 0 minus 12, the value is -12. We should take -12. And if we are having x is equal to 1, the value will be changed here, 1 square minus 1 minus 12. So I'm substituting in the given polynomials that values here. So 1 minus 1 minus 12 is equal to, we are having plus minus will be cancelled, -12 again we are having, so -12 I'm taking. And if x is equal to, then p of 2 is equal to 2 square minus 2 minus 12, 4 minus 2 minus 12 is equal to, we are having -10. And if x is equal to 3, p of 3 is equal to 3 square minus 3 minus 12, 9 minus 15 is equal to minus, we are having here the 6 minus 6, and the last term value x is equal to 4, then p of 4 is equal to 4 square minus 4 minus 12, 16 minus, we are having -16, it is the 0. Then we are having the value 4, the value of x is 4, then we are having the polynomial or y value is 0. So in this manner we are finding the p of x values or the y values. So we need to substitute these values in the, by plotting the points, we can join the polynomial to get the zeros of the polynomial. So I'm thinking this one is our graph represent our values. I will give you clear information to you how to represent the graph here. I'm drawing in the graph sheet. Just imagine this is a graph sheet, and I'm drawing axis, and it is the x dash axis, and I'm taking here y axis here, and here also this is the y dash we are having. So this is the point origin we know very well. And how should we take the values here? 1 2 3 4 5 6 7 8 9 10 11 12 I'm taking. Here also I'm taking 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19, 20. So in the both the manner we are representing x and y axis values here is same. So by taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So here we should take here the value should be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So why we are taking? This is the mandatory to represent the graph sheet taking the values of the scale. We need to write the scale value here. On x axis 1 centimeter is equal to 1 unit, and on y axis 1 centimeter is equal to 2 units. So in this manner only we are representing, based on the question we will represent the scale. So here we are representing the values. How should we consider the values here? So we need to take the negatives also here. 2, 3, 4, 5, 6, 7, 8, 9. I'm taking here also 1, 2, 3, 4, 5, 6, 7. I'm taking. So here I'm writing the values same in the same manner. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So in this manner we are having the values in the graph. How should we represent the values here? I'm taking the value here. X is minus 4. And the value is 8 where we are having. So this line indicates here. So minus 4 value is 8. So minus 4 and 8. And coming to the minus 3, and what we are having 0 means that point will come on x axis. And coming to the minus 2, and we are having minus 6 where we are having minus 2, minus 6 means we are having here. And after that we are having minus 1 and minus. So means downwards we are having here, means we'll get the value minus 3, 0, minus 2, so minus 6, sorry, here we'll get and we are getting minus 2, minus 6 value, and minus 1, minus 10 we'll get here the value is here, not here. And coming to the 0 when we are having the y value should be at 12, then somewhere we'll get on y axis. I am considering here I want to extend this one y dash value for our convenience. So I'm taking this is the one value, and this is also one value. So here this is the minus 10 we are having the value minus 10, and this is the minus 12 value. So to represent it is not clear, not using graph, so we are considering this one minus 12. This is the minus 10 value, and coming to the 1 means minus 12 we are having. So we are having same here, we are getting 1 minus 12, and 2 minus 10 we are having here, and 3 minus 6 we are having here, 3 opposite and minus 6 opposite, and 4 we are having 0 here we are having. So to join these points we are having the polynomial. This is the way we will get the polynomial. So the polynomial is intersecting in this place and in this place. Here we are having 0 and 4 0 value, and it is the minus 3 and 0 we are having. So here the polynomial is cut the x-axis in these 2 points. So these are the called zeros of the polynomial. We need to check, we need to verify this the values are right or wrong. So we need to check by using the factorization method for the given polynomial verification. How should we verify that? So our given polynomial is here we are having x square minus x minus 12. This is our polynomial. So by factorization we need to prove. Therefore x square minus x minus 12, here factors of 12 are 1 into 12 and 2 into 6 and 3 into 4. So by adding or subtracting we need to get the mid value, the x term value. We need to take here x square minus 4x and plus 3x minus 12 to get the 0. Here we need to take the values here. So here also 0 x into x of minus 4, and we need to take plus 3, and we will get x minus 4 is equal 0, and x minus 4 into x plus 3 is equal 0. Therefore x minus 4 is equal 0 and x plus 3 is equal 0, then the x value is 4, and here x is equal to minus 3. We are having the values same, so the value of x is here minus 3 and 4, so means we need to get for this one as 4 comma 0 is one value, zeros of the polynomial, and minus 3 and 0 is the one of the 0 of the polynomial we are having. This is the way we can represent the graph for the given polynomial. We can verify by using the factorization method. So this is the complete chapter.